Starting at the main induction valve, a line runs to the forward engine room to supply engine air. A line runs to the after engine room to supply engine air. A branch of this line may go to the maneuvering room to aid in ventilating this compartment. Another line from the main induction valve to the forward engine room is the main source of fresh air to ventilate the entire hull. The exhaust gases from the engines are discharged through the engine exhaust piping, the outboard exhaust valves, and through mufflers to the atmosphere. When the submarine is below the surface, the snorkel system may be used to provide air supply and exhaust. Air is taken in through the snorkel induction mast. It passes through a water separator to the snorkel induction valve and enters the system just below the main induction valve. The engine exhaust goes through snorkel exhaust valves to the snorkel exhaust mast. The induction and exhaust masts are telescopic. When the snorkel system is in operation, they are raised so that the head valve atop the induction mast projects above the surface, and the exhaust is a few feet below the surface. To prevent flooding, the head valve is electrically controlled so that it shuts when water passes over it. The exhaust mast has a diffuser which dispels the exhaust gases, thereby reducing the telltale wake. Hull ventilation is primarily controlled by a blower in the forward engine room. It forces air along the main supply line where it passes through air conditioning units. Branch lines supply the conditioned air to the compartments. The forward battery has its own booster blower and cooling coil, which is used to supply air to the compartment and to the forward torpedo room. Exhaust lines carry the air back from the compartments to the forward engine room. If the engines are running, they use this air and it goes overboard as part of the engine exhaust. Fresh air is supplied to the blower through the line from the main induction valve. When the submarine is submerged, outside air is shut off, and the air in the hull is recirculated by the blower. At other times, the blower may use a mixture of fresh and recirculated air. The battery ventilation system provides for removal of gases generated when the batteries are on charge. Each of the main batteries gets air from the living quarters overhead. This air is drawn into the battery space, and as it circulates, it draws off the battery gases through ducts. In some installations, the ducts are replaced by an open circulation system. The exhaust air is drawn out of the battery space by battery blowers and is discharged into the main hull exhaust line. Compressed air at various pressures is used for many purposes throughout the boat. Two compressors in the after engine room compress the air to a pressure of 3,000 pounds. An external charging connection also makes it possible to take on 3,000-pound air from shore. The air is distributed through a manifold in the control room to banks of storage bottles located in the main ballast tanks. Some of it is used at 3,000 pounds, some is reduced to lower pressures before being used. This diagram of the 3,000-pound system shows a bank of storage bottles and the manifold, which is divided into a receiving section and two distributing sections. The air goes from the storage bank to the distributing sections of the manifold. From there, it is routed through piping to blow special purpose tanks, to charge torpedoes, to charge the hydraulic air flask, and to bleed air into the boat. 3,000-pound air is also used as a source for lower pressure systems. Some is reduced by normal expansion to 600 pounds and delivered to the manifold of the 600-pound air system. This 600-pound air is used to blow the main ballast tanks. Other 3,000-pound air is reduced by reducers to 225 pounds. This air is delivered to another manifold. The air in the 225-pound system is used to blow the variable ballast tanks and to do such miscellaneous jobs as blowing water from torpedo tubes, blowing sanitary tanks, and sounding the ship's whistle. Some 225-pound air is further reduced and used for a variety of jobs where lower pressures are adequate. For this reason, this system is referred to as ship's service air. In addition to these systems, an independent 10-pound air system operates from a blower in the pump room. The air from the blower is led to a manifold in the control room. Lines from the manifold lead to the ballast tanks. When the boat is surfacing, 600-pound air is used to blow the main ballast tanks until the boat gets within a few feet of the surface. 10-pound air is then used to finish blowing the tanks. This conserves the high-pressure air needed to blow the tanks at greater depths. The hydraulic system of a submarine employs oil under pressure to operate such equipment as main vents, flood valves, outboard induction and exhaust valves, the steering system, the plane system, periscope and mast hoisting systems, and many others. Oil is drawn from a supply tank by a pump. It is delivered under pressure to an accumulator. From here, it goes to various manifolds which are connected to the hydraulically operated mechanisms throughout the boat. Each manifold is divided into a supply side, which supplies oil under pressure to the mechanisms, and a return side, through which the oil is returned to the tank. An even pressure is maintained in the system by the accumulator. As oil is pumped into the accumulator, it forces a piston down. Near the bottom, the piston operates a pilot valve, which actuates a bypass valve, so that the oil is bypassed back to the suction side of the pump. High-pressure air from a flask is delivered to an air chamber below the piston. As the oil is used, the air pressure forces the piston upward, thus maintaining an even pressure on the oil system. Near the top, the piston resets the pilot valve, which actuates the bypass valve, so that the pump again forces oil into the accumulator. This non-return valve maintains the pressure on the system when the pump is discharging through the automatic bypass or when the pump is shut down. The submarine's trim system is used to shift seawater ballast for fore and aft trim and for control of buoyancy. It consists of a trim pump, a trim manifold in the control room, and lines from the manifold to the variable ballast tanks, the negative tank, the safety tank, and to sea. This trim system makes it possible to pump water from any variable ballast tank to sea, or from the sea into the tanks, or to shift water from any one of the variable ballast tanks to another. The drain system provides for pumping of bilges. Lines from the bilges lead to a drainage line running the entire length of the submarine. The drain pump draws water from the drain line and discharges it overboard, or to the trim system, or to the fuel oil compensating system. If the water is discharged to the compensating system, oil in the bilge water will be separated out in the expansion tank, preventing telltale oil slicks. The drain pump also has a connection to the bottom of the collecting tank for the pumping of that tank when necessary. There are interconnections between the drain and the trim systems so that either pump can be used for either system. We have seen the most important equipment and machinery necessary for the operation of the submarine. The propelling machinery, which consists of the main engines and their generators, and the main motors, which drive the propellers. The engines are used to provide power for the motors when the submarine is on the surface or snorkeling. Batteries power the motors when submerged. The fuel oil and compensating system delivers fuel oil to the engines and replaces used fuel with seawater. The air supply and exhaust system supplies the air needed to run the engines, it ventilates the boat, and it removes engine exhaust gases. The snorkel system provides for air intake and exhaust when the boat is submerged. The battery ventilation system removes gases from the batteries. The compressed air systems distribute air furnished by two compressors. The air is stored in banks at 3,000 pounds pressure. This air is used directly or at reduced pressures to blow tanks, charge torpedo impulse flasks, and for general ship's service. The 10-pound air system is used to blow the residual water from the main ballast tanks when the ship is surfacing. The hydraulic system operates main vents, valves, and other hydraulic gear throughout the ship. The trim system is used primarily to distribute weight in the boat for fore and aft trim or overall buoyancy. The drain system is used primarily for pumping bilges. The construction of the modern submarine employs the latest developments in science and engineering to make it a formidable weapon against the enemy.